right, welcome back, welcome back. So this is the last push of this exam, I guess. I've connected everything in my circuit. Nothing has been programmed yet. So even though you can see a few lights on, nothing has been programmed yet. So let's see if I can work my way around this circuit. So here I have my buzzer. I've moved it from where I set in my pin connection because it was simply easier to put it across from, I think it's pin 13 or GP13 down to ground. I've connected my ground rail from pin 3 here all the way down to, it says plus, but it's actually ground. And I've linked those two as well just because it was a bit easier. Now, this looks a bit messy and a bit neat at the same time. Don't worry about that in the exam. Simply make sure things are connected in the way you said they are. And if you need to go back and change something, go back and change it. Here I have my two buttons, button left and button right. I have my red LED to the left, my green LED on the right. This is my I2C adapter linked directly to my LCD. Oh, here's my hall sensor. Now, luckily enough for me, I have an extra active buzzer here. So when I move this close to the hall sensor, that light should go off. There we go. See? So I can use this to actually test my circuit. Now, that's perfect. So now I'm going to start putting my system together. And I'm going to start with the hall sensor first. So I can say, while true, if hall sensor detects whatever it's supposed to detect, increase counter by 1 for good item, else nothing detected, decrease counter, but whatever the case is, right? I can always go in and change what I need to change. So this is my whole circuit here. Now let's have a quick rundown of everything I have. This is just my starter program. Nothing has been programmed. The only thing I've done so far is I've connected stuff and I've linked it to the pins I've used here. So let's go from the top. I say from machine import pin. So this imports a pin functionality. This allows me to use the pins on the Raspberry Pi Pico as inputs and outputs. So the GP pins, GP 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so forth. I've said import time. You can also do utime, or you could say from utime import sleep, so you don't have to type the entire thing. I prefer it this way. I said LED. This is the internal LED. I'm leaving it connected to pin 25. That's the only place it can actually be connected. I might use this for some random testing later on just to see if stuff is working. I've said green LED equals pin 17, and that's a pin out. So that's an output. Red LED pin 16, and that's an output as well. So as you can see, I've separated my LEDs, I've separated my buttons, I've separated my buzzer and my hall sensor. So I'm just going to leave this section separate from everything else. Let me click on that. I've said button left is pin 14 and button right is pin 15. They both pin in and they both are connected to the pull down resistor. That just makes sure it stays low until I press the button to make it go high. Buzzer is equal to pin 13 and that's pin out. And I've said hall sensor equals pin 18 and that's pin in. There's nothing else other than the LCD which I need to set up, but I'm going to do that later on. I have the hall sensor connected to pin 18 and that's obviously pin in. That's the input. Now the hall sensor is going to be the most central part of the system. That's what's going to detect what's happening if the mount body has a magnet inside of it. And what I've done here, I've said buzzer low straight away. Sometimes you might have this weird thing where even after you press stop or exit, the buzzer still keeps going. I've put a few things in to make sure that this doesn't happen. That's just one of them. I don't actually need this one, but I might as well leave it in. The first part here, this is just, I like to allow the sensors to warm up. So I give it roughly 3-ish seconds. So I just put a message on the screen as well, because again, it should be a user friendly system, and having prompts on screen, having messages on screen, that's good as well. I might put this stuff to the LCD instead of the screen because again, the person in the lab or the factory might not have a Raspberry Pi Pico connected to a PC, so it might make more sense to just use the LCD. So here we go. So the first thing I have good count and bad count. Now these two variables are going to be what keeps track when there is a magnet detected, so that should be good count should increase. When there's no magnet detected, bad count should increase, and I'm going to display both these numbers so there's no guesswork in how many good things there were and how many bad things there were. I've said while true, so I've created my infinite loop, and I've said try. What try does, it actually tries this without trying to push an error. So if something in here was bad or badly written, it wouldn't just crash the program, it would go again and try again and again and again because it's inside an infinite while loop. At the top of my program here, these are just things that I wanted to print out. So I say hall sensor value, and I print the hall sensor value there. I say good count, and I print good count there. I say bad count and I print bad count here. So this is just at the beginning of every loop, let's say, it prints out these values for me so I know what's happening. And then I say buzzer.low, again, just to ensure the buzzer starts off as being a low. Now this is where I do my check. So I say if hall sensor.value, so if hall sensor is equal to 0, no magnet has been detected, right? So turn the internal LED off, turn the red LED on, turn the green LED off, right? I say print, so this goes to the shell, no magnet detected. I might put this to the LCD as well. I say bad count equals bad count plus 1. All this does, it increments the variable called bad count. Remember, it started off as 0 at the very top. I've now added 1 to it. And if it keeps going around and around and around, this should increase if I have more bad counts. I also say buzzer.high. I sleep for 1 second and I turn the buzzer off. So I just let the thing beep beep for 1 second, then turn off by itself. Then I say elif, or if hall sensor value equals to 1, which means that if it's active, if it's working as it should be, if it has detected something, buzzer.low, just to make sure that buzzer is off, LED.value 1, so that internal LED turns on, the green LED turns on, and the red LED turns off. I print yes, magnet detected. Again, this is something I might put to the LCD or I might leave it on the shell. This really doesn't matter. The main thing that matters is the actual good count and bad count increasing as they should. And here I say good count equals good count plus 1. That means the good items have been counted, 1 more has been added. And I say utime.sleep1, so sleep for 1 second. And down here I just have an else. Now it's always good to have an else if you have if and elif. This catches any random weird thing that might happen. Sensors do play up sometimes, computers will play up sometimes. And I say there was an error, sleep for 1 second, and it will just go back to the top of the loop. Now down here, this is something you don't really need to do, but I like to do it because it makes my life a bit easier. I don't have to keep unplugging and plugging things in. I say accept keyboard interrupt, and I tell it what to do once there has been a keyboard interrupt. Now what that means is once I press the red exit button on my screen here, what this will do, it will turn the buzzer off if it's on, it will turn the red LED off, and it will turn the green LED off. And what I should actually do as well is do LED.low for the internal LED. So the internal LED is just called LED. So this will turn off all the LEDs and this will turn off the buzzer. So here's my system on my phone screen on the right, and my laptop screen is on the left, the bigger screen. I'm simply going to press F5 and show how the system works currently. Please pay attention to the shell. I don't have the LCD working as of yet. So because of that, all the messages that should pop up, they should pop up on the shell. Everything is not working perfectly, but this is just my version 1, let's say, of my program. Now you are supposed to iterate while you're programming your thing. So don't just sit there, write one big program, make everything perfect and go ahead and put that in your document. Increment things. So add the main features first, which in this case, the magnetic sensor, which is a hall sensor, that works to some degree. Then it does give some output. The LEDs do work. I believe the buzzer does work as well. So let me just press F5, have that start running. Right, waiting 3, 2, and 1. There we go. Now it's beeping at the moment. You might not be able to hear it perfectly, but it's beeping at the moment. And it's beeping because I've told it if nothing has been detected, if there is no magnet that's been detected, you should beep. Now I'm going to move a magnet close to the sensor and let's see what happens. Another quick thing you should probably note is if the sensor doesn't work perfectly fine, all you have to do, that blue thing on there, that blue thing there, that, let me try and get as close as I can, that is a potentiometer. Simply change the value until it does what you want it to do. So I'm going to bring my magnet here. So this is just an active buzzer. I'm going to bring it closer and it should stop beeping. There we go. Green LED comes on. That's now saying it's picking up what it should pick up. And on my system there, as you can see, I've got bad count 44, good count 11, 12, 13, because I've said just wait 1 second. And if I move this away, it should start counting the bad count again, 45, 46, put this back there again. So this is going to always be displayed on the LCD at some point. And again, the green LED goes on and off and on and off to tell the system that, okay, and detecting a magnet when it's green. When it's red, like now, and it's also beeping, there are no magnet has been detected. I've done a bit more. So this is going to be version 2 of the program. And the only thing I've really added to this one is the LCD stuff. So I'm going to try and skim over the stuff I've explained before and simply go straight to the LCD stuff. For example, all of this stuff here is more or less the same, nothing new. This stuff here, so these last 3 or 4 lines I've added, these are for the LCD. So with the LCD for the Raspberry Pi Pico, it uses the I2C adapter, and the driver files or the API files, I did not create these files myself. I went onto a few websites and I downloaded what they said would work. I tried it and it worked perfectly fine. For stuff like this, you should be given access to data sheets and some common commands for something that's not a part of the standard library, let's say. LCD is definitely not a part of the standard library, so this stuff should be given to you in the exam. So just speak to your teachers about that, right? So yep, I've from machine import I2C. I'm going to make use of the I2C method of communication. From LCD API, import LCD API. So there's an actual file called LCD API, and inside that file I have a class or a function or a method called LCD API as well. And from I2C LCD, that's the name of another file, import I2C LCD. So this first part here is the actual name of a file, and the second part is the thing I want from that file. So let me scroll down, 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 down. The very first LCD setup thing I have. So again, I've put all my code into separate blocks, and this part is called LCD setup. I2C address, mine is 27. In most cases with the Raspberry Pi Pico, it will be 27 or 39. Total number of rows or total rows, simply how many rows my LCD is going to have, and the total columns, the amount of columns my LCD is going to have. You don't need to focus too much on this section here. The only thing you really need to change is your SDA, so your serial data and your serial clock pins. I've opted to use pins 4 and 5. Well, it's actually GPIO or GP4 and 5, and the frequency 400,000. I've left everything the same. The only thing I've changed in here is SDA pin and SCL pin. And again, I've put mine as pins 4 and 5. Here again, we have LCD. We create a thing called LCD. We make use of the I2C thing we imported earlier. We make use of the I2C thing we created earlier. I don't want you guys to worry too much about this. Again, if you are using the LCD, you should have these basic setup commands given to you. You're not expected to remember everything from an API driver file. That's not something you need to do. You need to come up with the logic. Let me scroll down. I've changed my welcome message because before I only had it on the shell, but what I've opted to do is actually put it on the shell and on the LCD as well. So for example, it sleeps for 1 second here, then it says starting in 3, then I clear the LCD screen and I put starting in 3 on the LCD as well. So that first one that says print, that's going to be down here on the shell. And the second one that says lcd.putstr simply means put string to the LCD, starting in 3. That's going to count down on both the screen, both the LCD and on my shell as well. And I simply say starting in 3, starting in 2, starting in 1, and then the program goes into the infinite while loop I created earlier. Nothing new has been added here except for the part where it puts stuff to the LCD. So all the same information that was being put to the shell down here, which is where is it? The good count and the bad count. That's the only thing I'm putting to the LCD in this instance. So good count at the top, bad count at the bottom. So this way, someone can actually look at the LCD in, I think it was a factory or something, right? They can look at the LCD and see exactly how many bad items there have been and exactly how many good items there have been. Now, whatever gets printed to the shell, that's for me and you, the developer, the programmer, so that we can know what's going on whilst we're testing stuff. Nothing new here again. No LCD stuff here, no LCD stuff here. And in my else, I just turn everything on. So if there is an error, this is what's supposed to happen. There's just a crazy, loads of noise, loads of lights, loads of flashing, just so we know that something is happening that shouldn't be happening. And in my except keyboard interrupt, I've just turned everything off. My LCD, my buzzer, my screen, my LEDs, and I've also printed the good count and I've also printed the bad count onto the shell, just so again we can see what's happening. It might be a good idea to actually print these values onto the LCD and not clear it, but it really doesn't matter. We're just adding functionality here. So this is how version let's say I'm just going to call this version 2 of my system should work. I'm going to jump onto the circuit now and show how it actually works. Here I have my system again connected. I'm going to press F5 on my keyboard to run the code that's open now. Let's see what happens. Starting in 3, then 2, then 1. And as you can see, this is displayed on both my shell on my laptop and on the LCD as well. And as you can see here, let me try and come in. The count is being updated on the actual LCD as well. Sorry about the glare above. Let's see, that's a bit better. Yep. Now I'm going to move this in. So this thing here is going to be the thing I test my circuit with essentially. I'm going to bring this closer. The beeping should stop and the count on the LCD should start increasing for good count as well, saying yes, a magnet has been detected. There we go. It's going up 1, 2, and the same thing should be present on my shell on my laptop screen. So I'm going to move this away. It's now at 8, 9, 10, 11. The reason I've actually let it count this slow or this fast, whichever way you decide to look at it, is that let's just imagine the conveyor belt brought a new device under the magnetic sensor once every second or so. Now you can change this to whatever time you want, but I'm leaving mine as 1 second because it's a decent enough time that I can work with it. Another thing I thought about was maybe later on adding a motor, a stepper motor, to let it go into the left bin. So let's say the left bin is the one that actually gets done again or thrown away, and the right bin is the one that goes and gets packaged. Not something we need to do for now, because I do remember reading on the paper that they don't need us to mess with the conveyor belt stuff, but just a thought. I'm going to come in again, and as you can see on my LCD, it says good count 50. I'm going to move this away now. It should start beeping again. That red LED should come on and the green LED should go off. There we go. That's telling us that it's not detecting anything. Move this close again. And there we go. System is working as it should for now. I think the next thing I should probably do is maybe add the button functionality, so I can press one button to start the system and then maybe press another button as the emergency stop, and just start implementing that stuff. Let me just move to the very end, and as you can see, I have roughly 193 lines of code. This is massive overkill, because not everything here is needed, but I try to make it as simple but still as fully featured as possible. So let me go all the way to the top and let me see if I can explain. Oh, I left out a few comments, but that's fine. Please keep in mind, for the BTEC Level 3 Unit 6 Microcontrollers exam, you should comment every single line if you can. It doesn't maybe doesn't have to be every single line, but it should at least bare minimum be every section. So this is one section here for me, right? This is my LCD setup section. And for example, down here, this is my welcome messages to the shell and to the LCD section. So comment everything. I'm doing overkill. I'm commenting every single line if I can. I didn't do it for this section, but I will do it in the next one. I'll just quickly explain what this means. But commenting every line gets you marks as well. So please don't skip out on simple, easy marks, because you sat there and programmed this yourself. You should understand to some degree or very well what's happening. And if you explain it, that's going to be more easy marks for you to get moving towards a distinction. So I'm going to try and only show the stuff that has not been shown before. And the only thing I've added in this one is actually button functionality. And I believe if memory serves right, again, I'll share the entire paper for 2022 whenever it was. What happened on that paper was they wanted a stop button, like an emergency stop button. So I decided I should do a start button as well, because typically how factories work, when you're in a factory, you turn everything on in the morning for the very first time. There is going to be someone or something that tells you, okay, you need to hit the start button on this one. So that's what I've done. So let me run through the start of the program again. The welcome messages get displayed onto the shell, so down here on the Python shell and on the LCD as well. After that, I've got two functions, so we can ignore this for now. Let's fully ignore where it says define stop running. This is a function that is going to get called or is going to run when a button has been pressed. So I'm going to ignore this for now. It's a bit weird, but just bear with me. I have another function I created, which is all the stuff I had working before, which is, I've called it define main running. You can call it whatever you want. So this is the main running function where everything is working, okay? I've put that stuff in a function as well. Let's actually ignore this stuff as well. Bear with me on this. I'm going to skip over all of this stuff. You know all of this stuff anyway. I've explained this already. This is the part I want to go to first. So this is actually what happens very first when you run the program. It's at the very bottom and it's a bit weird, but you typically have to create your functions at the very top before you actually use them. So let me scroll back up a bit. This section here that says define main running, and I have the open bracket, close bracket, and the colon. This is me defining or creating my function, right? So I create the functions at the top and then I make use of them at the bottom. Let me just quickly click on the very end down here. So let's just say this was the very top of my program, right? I'm going to define function 1 and I'm going to define function 2, and then down here after I've defined them, this is where I actually make use of the function. So I can say function 1 for example down here, and this is how I make use of it. This isn't done properly. I've done functions in the past, so go back and watch those videos, but I'm just trying to explain the fact that you first must define or create your functions before you make use of them. Okay, so let me go back to explaining this section now. So when the program starts, this is what's going to come up first after the welcome messages have been displayed. And I've said while true, so that's an infinite while loop. I'll add the comments again at the end. And I say try everything inside of here. So don't just crash and not run anymore. If something happens that's not supposed to happen, try this. And if it doesn't work, listen for keyboard interrupt. And if it does work, or just go back to the very top and keep trying. What I've said is, if button left dot value equals 1, so if I press that button essentially, so the button on the left, I'm going to show that when I get back to my circuit, print start pressed, clear the LCD, and put on the LCD the start button has been pressed. Sleep for 0.2 seconds, so 200 milliseconds roughly, 20% of a second, and then go to this thing that's called main running and run that function. I don't care what that function says. That function could say print Bob the Builder 1 million times, go and run that function. So let me go over this one more time. If I press the left button, print to the shell, so down here, start button pressed or start press, whatever you decide is best, lcd.clear. Now the reason we keep clearing our LCD is that if we don't do that, the previous stuff that we wrote on there is going to get smushed between the new stuff. It's a bit weird the way it works. It doesn't automatically clear the screen. It will still have stuff on the screen whilst you're trying to write to it. So that's why before every time I write to the LCD, I clear the LCD first. I sleep 0.2 seconds just because, why not? You don't really have to sleep, but you might as well give it a bit of time to process what's going on, and we as a user can see it as well. 200 milliseconds is not that bad. And then I say run main running function. It's just called a function. It's just called main running. I can call it whatever I want. Maybe not the best naming convention in the world, but I've called it main running. And I've said, okay, if that button is pressed, do all of this stuff. Now I've also checked if the right button is pressed. I've got two buttons, one for start and one for stop, one button on the left and one button on the right. So I've said if the right button has been pressed, print stop pressed on the shell again down here, clear the LCD because we don't want it to have the stuff jumbled on there, and put to the LCD. So right on the LCD itself, stop pressed. So I'm going to have the text that says stop pressed both on my Python shell down here and on my LCD as well. Sleep for another 2 seconds, and on here I say stop running. So I'm calling the function called stop running. Right? We don't care what's in those functions right at the moment, but we're going to go back to the top. All this is saying down here, the except keyboard interrupt, is if I press exit while this code is running, it just stops everything and prints out good count and bad count. Because remember, we had good count and bad count being displayed on the LCD and on the shell before. But if I stop the program, I should ideally want to know how many things are good and how many things are bad. Not 100% necessary, but an added feature which I think adds to the overall user experience, which is something that we as the engineers have been told to do. Now, I've explained this section here. Let me go to these two functions now. I'm going to go to main running function first because that's the one that you guys know. So if I scroll all the way up, main running, this is this one here. So everything that I did beforehand, where I had good count, bad count, while true, I've just put all of that in a function. Nothing else has been added here other than putting everything I did before that worked inside of a function so I can call it, so I can run it, so I can make use of it whenever I want very easily. I think I added one line here actually, well, two lines. I say if button right dot value equals 1. So if that button is pressed essentially, that's going to be the emergency button. That's going to be the stop button. And if that stop button is pressed while this function is doing its normal thing, then it should go to that function instead. Now, we understand more or less what's inside the main running function. And again, you can change this to whatever you want. I just call it main running. Maybe not the best name in the world. And this is what happens inside that function, everything I've done before this. Now, the next thing I need to explain is the stop running function. So if I press the stop button at any time, someone's hand gets caught in the machine, some liquid was spilled, all the things are piling up, my supervisor said, stop running that machine quick, something's wrong somewhere, it doesn't really matter. Whatever the reason is to stop it, I stop it. So let's go to stop running as well. Where is that one located? I believe it's at the very top. Oh, here we go. Stop running. I simply print the very first thing that this function does. It prints on the screen, stop pressed. That's it. I should probably print to the LCD as well, but you know how to do that at this stage, so it's not really a massive thing. So I'm saying again, while true, so another infinite loop if I come into this function and I say try. And the reason I do try, I don't want my program to simply run once and crash and that's it. What a try will do, it will keep doing that same thing again and again and again until I press exit, until I press stop, until I tell it to stop. And in here again, I've said if left button is pressed, so if the start button is pressed, then start pressed. So what might have happened is at some point I press the stop button, then my supervisor says, oh, it's actually okay now. The water's been dried up, everything is okay, everything's working, everyone's safe. Start the thing again. I simply press the left button and everything will start as normal. So that's why it calls this function again main running. So this checks if the start button has been pressed, and if it has been pressed, do that thing. I'm saying if the right button has been pressed, I say, well, stop already pressed. It's already been pressed. Nothing else happens. It clears the LCD screen and it puts to the LCD stop. Stop has already been pressed again, and sleep for half a second. That's it. Nothing else. If no button is pressed once I've pressed stop, this is actually what happens. And what this is going to turn the LED on, the internal LED, turn the red LED on, turn the green LED on, turn the buzzer on, sleep for roughly 30% of a second, so 0.3 seconds, let's say, and then turn everything off. And this is going to keep happening again and again and again and again once I press the stop button and I don't press the start button again. This is what's going to happen. And what that's going to be is just going to be loads of noise, loads of LEDs flashing, just to indicate visually, so you can see it, and audio, well, not audioly, but audio as well, is going to be beeping, indicating to someone that, okay, this thing has been pressed. Maybe it's been pressed for a reason. We don't care what the reason is. This is what's going to happen by default. This is the generic thing that's going to happen once this function runs by default. And if in the process of me pressing the stop button, I press start, the program should start again. If in the process of me pressing the stop button while it's already stopped, it should just give me this message here on my LCD and on the shell, not terminal, shell. And that's it. And I have the same except keyboard interrupt as well. So if I press stop while it's doing this thing, this is what should happen. Hopefully that was detailed enough. Please pause the video, slow it down, go watch it again. Again, this is just a build up from the previous section. And just as a recap, the only thing I've added here is the button functionality. I'm going to now press F5 on my keyboard. So please pay attention to the shell and pay attention to the phone screen as well. Pressing F5 now. Now what you should see is that there should be some form of countdown saying 3, 2, 1. Then it should say system ready. Nothing is going to happen at this stage. So let me actually peel this plastic off. 1 second. There we go. That's much better. System ready. And with the system being ready, as you can see, I've got two buttons right there in the middle. One on the left and one on the right. The one on the left is the start button and the one on the right is the stop button. So I'm going to now press that one on the left, which is the start button. The system should start checking if there's a magnet present. There won't be a magnet present because the magnet is, let's say, there. And it should start beeping. Red LED should stay on. Red eye should flash. Let's see what happens. Yep. It's beeping as it should. Perfect. And keep an eye on the good count and bad count is increasing as it should. So bad count 7, 8, 9. I'm going to now bring this in and see if it actually does the count it's supposed to do. So bear with me. I'm using my hands here. Bring that close. Yep, it changes to green LED. And if you have a look there and on the shell as well, good count is increasing. It's now at 5, 6, 7, 8. Now it's only taken a second to update. I'm going to move this magnet away, move this active buzzer away, and it should start beeping again, and the bad count should start increasing again. Perfect, that's working the way it should. So let me leave that there for now. And what I'm going to do now is imagine the system's working as it should and my manager says, stop, you need to stop the machine for whatever reason. I'm going to now press the emergency stop button here. So the button on the right, that one on the right there for me, that's my stop button. Everything is counting as it should. Keep an eye on the shell as well. I'm going to press that now. See, stop button pressed. It's beeping, both LEDs are flashing there, the onboard LED is flashing, the buzzer is making noise, everything is trying to tell me, okay, something's going on here. Someone pressed the emergency stop button. And if you look at my shell as well, it says emergency button pressed. I might have pressed it twice quickly, but regardless, it works, right? Now, this has happened. Imagine we've wiped up the spill, we've taken the person's hand out of the machine, everything is okay, everyone is safe. I'm going to now press the start button again. So that the one on the left is the start, the one on the right is the stop. Press the start button, and as you can see, it starts counting again. Now I do have this tiny issue where whenever I do this, it prints everything on the same line. The numbers are correct, but it's just printing everything on the same line. Not a big deal in the grand scheme of things because everything works as it should. Which one is increasing actually? It is good count is increasing. I'm going to move the magnet away from here. And then bad count should start to increase now. Yep, buzzer beeping, bad count is increasing now. So the system is more or less working as it should. I have my magnetic hall sensor detecting whether there's a magnet or not. If there is a magnet, the LED comes on, the green LED comes on. If there's no magnet, the red LED comes on. I can press my start button. I can press my emergency stop button. I have the values being shown on the LCD there. I have the values being shown on the shell. So there's no guesswork as to how many good items there have been and how many bad items there have been. In my opinion, I think this is a really good way to improve I think it said user friendliness of the system, because no one needs to guess, oh, I wonder how many good things there have been. I wonder how many bad things there have been. It's there for them to simply read. The emergency buttons work, the start button works, and I believe, I'm going to review this at some point, but I believe that should be my entire program or system put together and working. I have done the circuit diagram for this. I have done the block diagram. I have done the pseudocode. I have done the flowchart. So if you're just coming into this series now, please go back and watch the previous videos, and they detail every single thing I've done up until this stage. All right. Thank you.